Hello, this video is just a quick update, diary I suppose, of my journey into trying to build my first Eurorack module. This is the version 1 that was designed by me and built by JLC PCB, and let's face it, it's very unexciting. It is simply an 8-line buffered mult, which means that if you put a signal in here, you get 3 copies of that signal out here. But one of the things I wanted to do is have some sort of LED visual representation of what's coming in, and then there's also an LED here which sits underneath the panel, so this little logo gets lit up. I mean, at its core, it's a probably the most basic powered module that you could make. It basically takes a signal, it then goes into an op-amp, and then so you send your signal into one of these chips, and then this chip then has 4 outs, and each of the outs goes to one of these 4 things, either an LED or 3 signals. I could have done 4 outs, but I felt like I wanted to have some sort of visual feedback. I built this using, or designed this, I should say, using Kicad, which I forced myself to learn after quite a few years of just not knowing how it all worked. So over Christmas I sort of kind of lived in it for a few weeks, watched a lot of videos, and yeah, figured out somehow how to kind of mash this all together. I mean, it's very much a DIY build. I mean, one thing I'm realizing is that through-hole technology is very big, and SMD would make a lot more sense for something like this, and you know, you could have just like something that did this job for this kind of depth, but you know, it's DIY, and overall it kind of works. So I'm kind of happy. I say kind of, there are a few things that I've learned that don't work as intended. So to explain that, basically I'll show you the sandwich effect. So I managed to figure out how to, it wasn't that difficult, but how to set up pin headers in the schematic. So I was trying to sort of separate the boards, so that this board here was really just holding the jack sockets, and I think there's a resistor in here as well, and an LED, but basically that's it. This is just an input board, and this board is the one that has all of the other smaller bits. So I tried to keep as much as possible hidden away inside the sandwich. But I can quickly show you here. I mean, you've got these 2 electrolytic capacitors which handle some of the larger power fluctuations. You've got 2 smaller 104s that deal with the high frequencies. You've got these Schottky diodes that give you reverse polarity protection, even though it's a keyed power jack socket, but seems to be the sort of de facto standard, I think. And then you can see the chips here, 1, 2, 3, 4, 5, 6, 7, 8, and for each chip you've got another 2 decoupling capacitors at the negative and positive rails, just to help with that power stability. And then each of the outs has a 1K resistor. That's kind of it. There are only a few different ingredients in this. It's very, very simple. I've used sockets for the chips in case anything went wrong, so that adds a bit of depth, but that's not really a big deal. I managed to get a little image just to play around with the silk screen stuff. So I just wanted to have a go at putting something together that sort of explored a few things like layering, using these headers, graphics, the LED stuff down here. So I'll just plug it in quickly and I'll talk through some of the problems that I had. Actually, I'll show you the first problem. I had put this header in the wrong way round, which isn't that big a deal, luckily, because it's got some space here, but it kind of does that, and it should flop down this way, but it still works, it still fits okay, so that's not the end of the world. Right, let me just get this all hooked up. Okay, so yeah, I kind of put this together really to go with PAMS, because Pamless has 8 outputs, so I thought it would be useful to have something that allowed me to take each one of these 8, so permanently patch these into this along here, and then I've got 3 versions of whatever I'm doing in PAMS. So first thing to note is there is bleed through. So the light is obviously working under the silk screen, and that's kind of the effect I wanted, but the LED is too close to the surface, which means that you get this very strong effect in the middle and it kind of quickly dissipates on the side. So maybe I need to put some reflective stuff in there, or maybe 2 more LEDs, possibly using the same resistor. But you can see also here that this is being lit up even though it's not being used. So that's a bit of an issue. So maybe I need to sort of kind of wall it off a bit. But yeah, let me show you another thing that was a problem. Basically, I've used 1K resistors for all of these, but actually that makes these LEDs extremely bright. So I need to change those out. So if we took, say, this number 1 here, so it's not showing the same level of detail as you're getting from this LED here, which is being driven by a digital machine. So I'm not sure at this stage if that is correct. Let me take this basic square wave from number 4. And you can see here, that's more in line with what I was hoping for. That seems to be working. Then we've got this faster square wave here. So that seems to be okay. I mean, that I can see that is fluctuating as this is now. Part of the problem, one of the problems was I used the wrong size LEDs. These are 5mm. Actually, what I need is 3mm, because they will then come through the holes rather than hide it underneath the faceplate. So that's one change I need to make. So let me show you the main problem. So let's take basic obvious square wave from channel 4, and I'm going to put it into channel 5 of the mult. And then let's take channel 2 and I put it into channel 6 of the mult. So what happened is I've messed up the pin routing, which means that anything coming into input 5 is being sent out to output 8. That is going here, that is going here, and that is going here. So that's a problem. Not a massive problem, but it does mean that I need to figure out and learn how to cut traces. So I'll just show you what I mean. So what is happening is on the input board, let's take this last one here. This is going into, or going through and coming out of this last pin down here, which is pin 30. And it's on the other side, it's coming into pin 30, which is fine. And what it should be doing is going to the op amp, the chip. So there's 8 chips, 1 chip per line. It should be going to the chip that is feeding this, but it's going to this. And I remember getting quite confused about the routing in the schematic, and I've already seen the problem, which is easy to fix in the schematic. And basically what that means is to fix this properly, I would need to get the boards remade, which I may still do, but I kind of feel that because this is a DIY project, I mean, the whole sort of the look and feel of it is very DIY. It's all through hole, it's very big. I'd like to try and make it work, because it's the first thing I've ever done. I want to try and make it work as a point of pride, I guess. So what I need to do, so you've got traces on both sides, and you can see here, maybe you can't see in the light, but there's a trace here that goes to an op amp, and I'm going to need to check the schematic to know exactly where it goes. But what I'm planning to do is cut this trace here and route that using wire to somewhere else. I haven't quite figured out how I'm going to do that yet. So it's easy enough to find the traces that come out of these pins. Most of these pins are ground. There's only 8 pins that have signals from here. So I somehow need to figure out, finding and cutting the trace is easy. Then I need to scrape away the silk screen and put a jumper wire in and find the input for the right chip, cut that trace. Maybe I don't need to cut it, but anyway, I need to find it and scrape that away and create a sort of a jumped circuit using very thin 30 AWG. I don't have that, but I've got some jumper cables that I can use. So yeah, that's the plan. So yeah, it's mixed success, I'd say, but it's been a really enjoyable experience. For me personally, this has been a big blocker for a very long time, and I think back when I first sort of got into all of this stuff, it was from watching a video about making MIDI controllers, and I could do the breadboarding okay, that's quite fine. Strip board, proto board, that's all cool, but there seemed to be such a big jump between that and using CAD software, like design software for this sort of stuff, where every sort of fraction of a millimetre is important potentially. And I found that really quite daunting. And really the way to get around that is just to find the right tutorials, and I will put some links in the description to show you where I went for those tutorials. And just sort of get into it and just dedicate, you know, a good 10-20 hours across a couple of weeks, and just sort of play around with it. So since building this, so I built this, shipped it off to JLC, and then I've since then just been putting together more and more design projects in schematics, and some of them are also designed in a PCB editor. And I'll do another video at some point just sort of talking through my own thought process for how that stuff works, because even though there are lots of videos about Kicad, there aren't that many that I've found that do sort of cover specifics around DIY synth stuff. And this is Eurorack, obviously, but the principles apply to sort of desktop synths as well. But yeah, if I can, if it's helpful, I would be happy to sort of do some videos to show my sort of do a screen share and walk through my thought process for really the two key phases, which is designing your schematic and then transferring that to a PCB editor, and where the real fun is doing all your trace routing, all the wires and lines and everything. That I found that to be a wonderful puzzle. Anyway, that's it. Hopefully that was useful, and if you've got any questions, obviously I'm always responding to pretty much everything. So anyway, hope that's useful. Thank you. Take it easy.